This is lesson 7.2 for Algebra 2 on equivalent quadratic forms. So there's three different quadratic forms. The first is general form. This is what we're kind of typically accustomed to. This is y equals ax squared plus bx plus c. So for example, it might be like y equals 3x squared plus 12x minus 16 or something. In that case, c would just happen to be a negative 16. Then there's vertex form, which we talked about a couple sections ago. Vertex form is y equals a times x minus h squared plus k. And the vertex is at hk. The place that students get a little bit tripped up here is you have to be careful that if this is a minus h, it's positive in the coordinate. If it's a positive here, then it's going to be a negative in the coordinate. So it's basically the opposite of whatever you see. So for example, y equals 2 times x minus 6 squared plus 7. The vertex would be a positive 6, comma 7. And then the last form is factored form. Factored is when you have two sets of parentheses. So it would be a times x minus r1 times x minus r2. So maybe y equals, I don't know why I'm using 3 so much. I'll just pick a different number. 5 times x minus 6 times x plus 4. This would be factored form. And R1 and R2, just to be really clear, those stand for your roots. Those are sometimes called zeros or solutions or x-intercepts. I'm not really sure why there's 9,000 names for them, but they're important enough that they need to be named 6 million different things. So with a parabola, these would be your R1 and R2. Those are the two places that they cross the x-axis, and that's those right there. So there's something called the zero product property. This is a really fancy way to say something really simple. It says that if a times b equals 0, then one of the two of them must be 0. So a equals 0, b equals 0, or a and b are 0. For example, 7 times a equals 0. It's pretty clear that a must be 0. If it was like 12 times b equals 0, it's pretty clear that b must be 0. It could be 0 times 0 also. So that's what the zero product property says. The reason that's important is because when we get to these factored forms, when you have the factored form, x minus 7 times x plus 3, and that equals 0, we use the zero product property to solve for the x values, to solve for the roots. So what we would do is take x minus 7 and set it equal to 0, and we'd also take x plus 3 and set it equal to 0, because one of those two chunks must be 0, and solve. So x equals 7, and then here minus 3, x would equal negative 3. So if we were going to graph this one, it would look like something like this, where we have a solution here at negative 3 and another one here at 7. Now, number 2 says the graph of a quadratic equation is shown. Write the function in factored form. So they gave us this graph right here, and they want us to figure out what equation it came from. So these are our two solutions, or our two zeros. What you might have noticed up here is if we started with the factored form being x minus 7, the solution was plus, or positive. Here, when it was x plus 3, the solution was negative. So working backwards here, it's negative 3 as a solution. So in the original factored form, it would be x plus 3. And then here we have a positive 4, so in the factored form it would be x minus 4. So this would be factored form. Just for giggles, if you wanted to put it in general form, that's the one we're used to seeing. You would FOIL this out, and you would ask what negative 4 times 3 is, which is negative 12. Negative 4 plus 3 is negative 1. So you'd have x squared minus x minus 12 equals 0. Well, we just did this. It says to write the equation from number 2 in general form. So we had x plus 3, x minus 4 equals 0. When you FOIL that out, you get x squared minus x minus 12. If you guys wanted to, you could set up the box. X times x is x squared. This is 3x, negative 4x, negative 12. Combine those, and you get, again, x squared minus x minus 12. But the shortcut I just prefer because it's a little quicker. All right, this one is a little bit more intensive. I'll start these off, but then I'm going to pause the video because I don't want us to get cut off. So what we have to do in this is we need to convert these into factored form. I will start with the more challenging one, and then we'll end up with the nicer one. So when we convert this first example.
Good afternoon.